All right, in this video, I'd like for you to concentrate on the portion of your notes that we skipped. So if you'll go back to the first page, but the back side. And at the top of the back side, we have a little section called the second derivative test. And this can be a little misleading. It seems like since I just introduced concavity and we use the second derivative, that maybe the second derivative test has to do with concavity. But actually, it is a shortcut. So the second derivative test is a shortcut for finding maxes and mins. So this is a shortcut for extremas, finding the relative extremas. And so the way that the second derivative test works is you have three conditions that you have to look at. First of all, if f double prime, so make sure you realize all of these are about f double prime. If f double prime is positive, then you have a relative min. If f double prime is negative, as in that second row, then you have a relative max. And then this is the one you need to remember. If f double prime is 0, then the test fails. And you would have to go back and use a chart as what we did in our quiz that we just took the other day. Now, I want to be sure that I'm clear about when I'm saying f double prime is positive or f double prime is negative. Because notice that it has a c substituted in for the f double prime. Those c values are the critical numbers. So you're substituting in critical numbers. And that's what we're looking for. You're going to sub in critical numbers to f double prime. So subbing in critical numbers to f double prime, and then looking for whether or not you have a positive, whether you have a negative, or whether the test fails, and instead you have to make a chart like what we did in your previous lessons, and you just took a quiz over. So you'll notice that in your steps, so now I'm going to have us look on further down the notes page here. In your steps, step number 5, if you are asked to find relative extrema, then in step number 5, as you're fully beginning to analyze a graph, if you have an easy second derivative to do, and keep in mind, I would never do this unless I had an easy second derivative, then you can find your critical numbers, and at each critical number, you can analyze the sign of f double prime. And so, again, I've just repeated what I said was the second derivative test. So this description right here is the second derivative test. And notice that if the second derivative test fails, that you have to do your table like we did in your other lessons. So now if you'll go to your example, we're going to continue on with that example. So the second derivative test. Now, I'm going to need to go back and have us finish up just a little bit of work. So our f prime for this function, again, from what we did before, was x to the third minus 4x. And this time I need to go ahead with it and find our critical numbers. So that means I'm going to have to set x to the third minus 4x equal to 0. There won't be anywhere where it's undefined, although you should always check that. But we do need to see where that equals 0. So we can factor out an x, and that will leave us with x squared minus 4 equals 0. And so there are a variety of ways you can deal with the x squared minus 4, but definitely realize that you have x equals 0, and then you have x squared minus 4 equals 0, and you could factor that, or you could say x squared equals 4 and square root and get x equals plus or minus 2. So you have 3 critical numbers, and they are 0, so that's a critical number. And then you have 2 and negative 2, so those are both critical numbers. And you're going to do the second derivative test. So the second derivative test, using your second derivative. So let's repeat what that was. F double prime is 3x to the second minus 4. The second derivative test says that you will substitute in your critical numbers. So you've got to substitute in 0, 2, and negative 2. So we'll first of all do f double prime of 0. Okay, well, f double prime of 0, I'll plug in 0, 3 times 0 squared minus 4. And all that I care about is this positive or negative? So this is going to be 0 minus 4, that is negative, and therefore my conclusion is that I have a relative max. So you can go back and look. You can think of it in this way. If your second derivative is negative, then that's going to be concave down, and so you would have a relative maximum. That's going to be 0 for your x, and if you substitute it into your original problem, you would get 0 for the y. So make sure that you do this by going into the original function. So the original function there. And then let's take a look at f double prime of our next critical number. So I listed 2, f double prime of 2, 3 times 2 squared minus 4. So that would be 3 times 4, which is 12. 12 minus 4 is 8. That's positive. Because that's positive, think of that as concave up. So you would have a relative min, and that ordered pair would be 2. And then going into the original problem, you would get negative 4. And then finally, f double prime of negative 2. So f double prime of negative 2. So that would be 3 times negative 2 squared minus 4. You're actually going to get the exact same answer as what we got in the line above. So that's positive. And again, you have another relative min. And its ordered pair, negative 2, negative 4. And remember, whenever you're finding these ordered pairs, you sub into the original problem in order to find the y value. So this is how the second derivative test works. Again, this test is only useful if you have an easy second derivative to do. And if you don't, then you can always fall back on doing a chart with your intervals established by those critical numbers, the sign of f prime, and the characteristic of f.